Next question, which is question number 40. A settling tank in a water treatment plant is designed for a surface overflow rate of 30 meter cube per day per meter square. Assume a specific gravity of sediment particles 2.65, density this much, dynamic viscosity this much. Stokes' law is valid. The approximate minimum size of particles that would be completely removed. We need to calculate the size of particles, that means a diameter of the particles. Surface overflow rate, that means V naught is equal to 30 meter cube per day per meter square. Specific gravity 2.65. Density of water is 1000. Dynamic viscosity mu is equal to 0.001. All units are standard units, so I am not writing the units. The approximate minimum size of particles. So the Vs formula we can write as rho g d square g minus 1 upon 18 mu. Density is 1000. G value is 9.81. D square we don't know. G is 2.65 minus 1 divided by 18 into 0.001. So if I calculate the value of Vs comes out to be, so the value of Vs comes out to be 899250 d square. Now they are saying that the approximate minimum size of particle that would completely remove. Completely remove means we know the efficiency will be 100%. So efficiency will be 100%. That will be equal to Vs upon V naught into 100. So this implies that velocity of settling velocity will be equal to the surface overflow rate. Surface overflow rate is given that 30 meter cube per day per meter square. So Vs is equal to 30 meter cube per day. In a day there are how many seconds? Because Vs comes out to be in standard units, so day should be changed into second. So 24 into 60 into 60 meter cube per second per meter square. So, and the value of Vs, obviously we have calculated value of Vs is 899250 d square. So 30 24. So the value of D diameter comes out to be 0.0000165 meters. So the answer they want is in the approximate minimum size of particles that would completely be removed is in mm. So in mm it will be 0.01965 mm. I can write it approximately 0.02 mm. So the diameter comes out to be 0.02 mm. I can write the answer number B. Next is, a town is required to treat 4.2 meter cube per minute of raw water for daily domestic supply. Flocculating particles are to be produced by chemical coagulation. A column analysis indicated that an overflow rate of 0.2 mm per second will produce satisfactory particle removal in a settling basin at depth of 3.5 meter. Required surface area they want to know. Alright, so they have given us the value of, first of all, the discharge is given, that is Q is equal to 4.2 meter cube per minute. Flocculating particles are to be produced by chemical coagulation. Column analysis indicated that the overflow rate SOR, that means V naught, is equal to 0.2 mm per second. I can say 0.2 into 10 to the power minus 3 meter per second. I can change this is also 4.2 divided by, in a minute there are 60 seconds. So per second, meter cube per second will be the discharge. Now I got the SOR as well. Now the particle removal depth is given at required surface area, the amount of the settling tank. So we got the surface overflow rate here. If I want to calculate the surface area, that will be nothing but Q upon SOR. Q is 4.2 divided by 60 and SOR is 0.2 into 10 to the power minus 3. Surface area will come into meter square. So if I calculate it down, I get the value of 4.2 divided by 60 divided by 0.2. So the answer comes out to be 350. The value of surface area is equal to 350 meters square. Correct option is option B. Let's move on to the next question, which is chlorine gas 8 mg per liter SCl2 was added to drinking water sample. If the free chlorine residual and pH was measured to be 2 mg per liter SCaCl2 and 7.5, what is the concentration of residual OCl minus ions in the water? Assume that the chlorine gas added to the water is completely converted to HOCl and OCl minus. Atomic weight of Cl is 35.5. The reaction here is given, that is this is the reaction, right? OCl minus plus H plus at particular value of K becomes HOCl and K is 10 to the power 7.5, and HOCl will again change into H plus and OCl minus at particular pH. The value that of pH is given, see the pH is given as 7.5. So I can say that H plus ion concentration is equal to 10 to the power minus pH, that is 10 to the power minus 7.5. Now the free residual chlorine is free residual chlorine is nothing but HOCl plus OCl minus. This is known as free residual chlorine. Now the free residual chlorine value, free chlorine residual or free residual chlorine is equal to 2 mg per liter SCaCl2. I can write it as, this is equal to 2 mg per liter as Cl2. If I change it into grams, it will be 2 into 10 to the power minus 3 gram per liter as Cl2. And if I change it into molecular weight in moles, so it will be 2 into 10 to the power minus 3 divided by molecular weight of Cl2 mole per liter. Free residual chlorine. So I have changed mole per liter, that means I have changed it into concentration, right? So concentration of what? Concentration of HOCl plus OCl minus comes out to be 2 into 10 to the power minus 3 divided by, what is the molecular weight of 2Cl? That is 35.5 plus 35.5. It is equal to 71. So if I go further, I can say that HOCl concentration is nothing but 2 into 10 to the power minus 3 divided by 71 minus concentration of OCl minus, right? And we have given the equation, the reaction is given that OCl minus plus H plus ion will give us HOCl, where K is 10 to the power 7.5. That means here K is equal to HOCl concentration divided by H plus ion concentration into OCl minus ion concentration. K value is 10 to the power 7.5. OCl value, HOCl I have just now calculated, that is 2 into 10 to the power minus 3 divided by 71 minus OCl ion concentration, and H plus ion concentration, just now we have seen H plus ion concentration is nothing but 10 to the power minus 7.5. So it is 10 to the power minus 7.5 into OCl minus. So this comes out to be, if I cross multiply into 10 to the power minus 7.5 into OCl minus is nothing but 2 into 10 to the power minus 3 upon 71 minus OCl minus ion concentration, and this gets cancelled out. I get OCl minus concentration, and if this minus also I get this side, so OCl minus plus OCl minus 2 OCl minus is equal to 2 into 10 to the power minus 3 upon 71. 2 to 2 cancelled out. I get the concentration of OCl minus ion as 1.408 into 10 to the power minus 5 mole per liter. So they were asking me the concentration of residual OCl minus ion. The answer comes out to be 1.408 into 10 to the power minus 5. So the correct option is option A. Next question is 43. A horizontal flow primary clarifier treats wastewater in which 10%, 60% and 30% of particles have settling velocity of 0.1, 0.2 and 1 mm per second respectively. What will be the total percentage of particles removed if clarifier operates at surface overflow rate of this much? Alright, let's move on to this question. If settling velocity of any particle, it is more than the overflow rate, surface overflow rate, then the particle will be settled down, right? So I can say that it is 100% removal. Efficiency is 100% if the settling velocity is greater than the surface overflow rate. And if settling velocity is less than surface overflow rate, then I say that percentage removal is nothing but settling velocity upon SOR into 100. For us, the surface overflow rate is given, that is 43.2 meter cube per meter square per day, right? If I change it into particle size is given into mm, so let's change this meter into mm. So 43.2 in 1 meter there is 1000 mm, and per day there are 86400 second. Alright, we have changed the surface overflow rate into the normal mm per second value. So after calculating it, we get 0.5 mm per second. So the surface overflow rate comes out to be this. The question is that what would be the total percentage of particles removed? Total percentage of particles removed. We have given here that for 10% the particles, the surface overflow rate is that means settling velocity I can say that is 0.1 mm per second, and for 60% of the particles the surface overflow rate, the settling velocity is 0.2 mm per second, and 30% particles the settling velocity is 1.0 mm per second, and this is greater than surface overflow rate that we have calculated. So I can say that just now I have seen that if settling velocity is greater than surface overflow rate, 100% removal will be there, right? So the 30% particles which have the velocity greater than surface overflow rate definitely will be removed 100%. So 30% particles will be removed fully. So the total percentage, if I want to calculate, is 30% will be removed fully. Okay, so I can take full 30%. The 10% particles that will be removed, that will be 0.1 is the velocity of this divided by surface overflow rate 0.5 plus 60 into the velocity is 0.2 divided by 0.5. So the value comes out to be 56%. So the total percent removed will be, answer will be 56%.